ahead, a quick intro about me. So I'm part of the AWS Ambassador community, and since 2019, 2020, I'm part of the Ambassador community, and I'm working with AWS since last 8-9 years odd. And I started as a technical architect in cloud, and I wanted to start with AWS, and I've been fortunate enough to be part of AWS cloud until now. My professional life, I'm working as an AI enterprise architect in TCS, close to 22 years of experience. In my free time, I try to write as much as I can. So I have written close to 50 blogs in Medium, quite a number of artifacts within my organization, and here and there in LinkedIn, CIO.com. So that's a brief intro about me. So before we move ahead, a quick gist of what we are going to do. So this is going to be a deep dive on AWS Strands, how we can use it to create independent AI agents, and also very important, the topic in today's era is how do we productionize AI agents, because there is a lot of doubts among industry experts whether AI agents can scale, whether AI agents are secure. Can it actually work in a high secure and high scalable industry like a bank, like a retail? There are many questions which are coming from customers, and today's session will hopefully clear most of your queries. Okay. So Agentic AI, quick few seconds before we delve into Strands. Okay. So I'm sure most of you are using LLMs. Can one of you tell me what's the difference between LLM and an agent? When does a LLM become an agent? What is a LLM and what is an agent? Anyone? Is LLM independent? Can LLM be independent? Can it do things on your behalf? Can it book a ticket? Can ChatGPT or a Claude or a Llama model or Nova, can it book a train ticket for you? Can it it can create an itinerary, a holiday plan, but can it book your hotels? Can it book your flight tickets? Does it have that intelligence? So that's the autonomous capability that we are looking at. So close to 2 years back, there was this huge exploration of large language models. So there were models trained on humongous volume of data. It knew everything. You ask anything and it can answer. Then we had a period where the LLM was trained up to the latest and the greatest data which you have. So it was no longer outdated. It was trained on the latest data. But still, there was something which was lagging. It was not intelligent. It was not something which can do tasks on our behalf. So it was lacking certain amount of independence. So that it was a kind of dumb, because all it does is you ask a question, it gives you an answer. Now then came an era where we went on creating MCP, we went on creating tools, we went on creating APIs were already there, but we went on creating integration mechanisms where these LLMs can talk to these APIs. So that is when the LLM started gaining intelligence. So it matured from a LLM to a program which can execute certain actions on your behalf. It started having certain context. So earlier when you used to ask and you get a response, the second question did not have any relation to your previous question because it did not remember It did not have your context. It did not have your industry context. So it was kind of a question answer bot. But now, with AI agents, it has memory, it has context, it has the intelligence to take any action on a human's behalf. And that's when it started becoming independent. We saw so many browsers coming up which can open a browser, fill a form for you. You have heard about Comet, and many browsers are there which have the agentic AI capability. You have Kiro, which is an agent actually. So it is a coding agent where through repetitive reflections, it's able to suggest the best code which is suiting your requirement, your specification. So it has a context, it knows your profile, and accordingly it suggests code, right? So it is taking over what we used to do, and then there came this large hype of, oh, is AI taking my job? I don't want to get there, but yeah. So that's how those discussions started coming up. So today what we are going to see is how we can create such independent agents using Strands. Okay. So I think I have mostly touched upon this. So how does an organization benefit from agentic AI? So we can apply it to every industry, any industry you name it, and customers are just loving it. I'm having discussions with customers across the globe on a day-to-day basis. When they see how much AI is able to do, it's a revelation for them. So I'm talking about the layers of business CXOs who are not so much savvy with the AI tools. When we show them the capability, they are awestruck, right? And they want to adopt AI agentic solutions for their industry and for their internal organization. So this list will not do justice, but I've just put down the trends that I'm seeing with the customer conversations I am having. Okay, so Strands agents, I have worked with LangGraph, LangChain, Autogen, and then Crew AI. What I have found is Strands addresses all of the doubts that you have in your mind before you think about scaling AI agents or productionizing AI agents. First and foremost, security. Since Strands is from Amazon, it tightly integrates with Bedrock. And Bedrock, close to 3 years back when it was released, Amazon started thinking about security in the form of guardrails. Now guardrails have matured pretty good. You can do masking, you can control how your agent should behave, everything. So this has a major advantage where you can easily bring in all the security features which you have in Bedrock. So one is security. Then scalability. You will see all the features that it has. It has all that you need to create a scalable agentic AI system. So what this slide shows is there is this feature called agent loop in Strands. You will see this pattern in other frameworks as well, in other mechanisms as well. For example, agent-to-agent protocol. Some of you might have heard. It's famously called A2A protocol, where one agent talks to another agent. So this is nothing to do with AWS. This is a industry terminology. Similar to that, there is a concept in Strands called loop. What happens here is there is a LLM, and then there is an agent. Agent will use a LLM to call a tool. The tool will get processed, it will get a response. The response will come back to the LLM, and then it will call another tool, and the response will come again. So this happens in a loop. So with this capability, what we are able to do is, we can call multiple tools. We can encapsulate multiple tools for one functionality. So that helps us to create sophisticated agentic systems. And these are some of the features that you see of Strands. So Strands, another powerful feature is it is not tied to Amazon LLMs alone. In the demo that I have built for today, I have used GPT-4o. You can bring in any LLM that you want, and Strands will be able to communicate with that. Okay. So these are the benefits for industry: multi-agent, deploy anywhere, scalable, and of course the time to market is very less. Okay, so I was talking about loop. So this just tells you an introduction about a loop, which I already briefly mentioned before. I have a detailed blog on agent loop, and the picture that you are seeing is the thumbnail of my blog, so that's why I had put it here. I have this tendency of trying to see what lessons we can take from nature, and what this is personal to me. So it may not be sensible to you, but I felt it is a common pattern. So there is this pattern among honeybees. It's called waggle dance. What the honeybee does is, there is a hive. We all know honeybees come from the hive. They move across flowers. They look for nectars, and they come back to the hive, and then they go back to the flowers. So they keep doing this in loop. What happens is, a honeybee, it starts from its hive. It first goes to a set of garden or flowers, and it comes back to the hive, and it does a movement, a certain set of movement through which it tells the other honeybees information about what the flower is, where it is located, and how much of nectar it's possible. So this information is passed on to other honeybees, and they follow it. So what I'm trying to say is, this looping of coming back to your origin and then passing your information and having setting up a collective intelligence is something nature is already doing it. And the agent loop which you are seeing, even in an A2A protocol and many other frameworks, it's the same concept, where a tool is called and the intelligence comes back to the originating LLM, and then that intelligence is passed on to another tool, and then it comes back. So there is a collective intelligence which is created here, and that's the pattern which I'm trying to articulate through this blog. So when you get time, read about it. It will be an introduction to Strands, to agent loop, sorry. So this is just a pictorial representation of what happens in a typical agentic workflow. So not only Strands, there are many tools, N8N, Zapier, even OpenAI released Agent Builder stack, then there is Agent Space from Google. So all of these, they have this high level steps. First and foremost, you have the initialization, then you have the user input. So first you start with an input. You say, this is what I want to do, or this is my goal, all right? And then that input goes to a model, to a LLM. So that's a processing that you need to do. And then you need to understand what it is giving you back. You need to do a response analysis. If you are calling any tools, you have to execute that. Then comes the tool result processing. So you have to process what the tool output is, and then you have to do the final processing. So this is, no matter which framework you are using across the world, this is the high level workflow steps that you need to think about. Okay, so after agent loop, another feature of Strands is the ability to maintain memory. Okay, So when you are asking a question to a LLM, say for example, there is a food ordering app, okay, and you want to do an online order, and you want to pick your order from the store. So this is your very simple requirement, and you tell the LLM, I want to order a coffee and a sandwich. Then then the LLM asks you what type of sandwich you want. Then you tell your sandwich. Then the LLM might ask you, what's the size of your beverage? Is it small, medium, or grand? So you give your answer. So there will be say 5 or 8 to and fro questions, and then there is an order summary. Then imagine there is there is some outage, or there is a connectivity issue and the link is broken. So when you get back to the same chatbot, you expect the chatbot to know your earlier conversation. If you take a normal LLM, it will not remember what you said before. So you need to bring in certain memory, and in Strands, there are features like session management, memory management, which helps you to create and maintain these sessions and memory. So there are 2 options in Strands. You can use S3 to ensure that there is this continuity in session. So you can store data in S3 bucket, and it also allows you to store data in file systems. So that these are the 2 different ways in which sessions can be maintained in Strands. So this helps you to easily have a memory in your interaction. Other feature is prompts. Obviously, every agentic solution has prompts, and prompts is very important. That is what defines how the behavior of your agent is going to be. So there are many different prompting techniques, few shots, example shots, and so on. A very basic prompt should have a role, it should have an action, it should have context, and then it should have an execution. So without this basic requirements, there is no prompt. And it's very important for you to understand the prompting techniques and which prompting technique has to be applied for your use case. Okay, so next is hooks. So hooks is also this feature which makes Strands unique. What you see is a screenshot from the Amazon Strands documentation. So I've just taken it from there. This diagram is not from me. Yeah, I don't think it's clear enough, but yes, if you refer the documentation hooks, you will get this diagram. So here you have events which you need to override. So what hooks helps you to do is, whenever you want to do monitoring or validation or any error exception, for example, if LLM gives such a response back, call this tool. Or if you know that these kind of errors can happen, like how you do exception handling, you can use this hooks feature. And there are predefined events in Strands which you can override, and you can write your logic. So that's about hooks. Next is you can also process, or you can also define how you want the output from the LLM. So you might want the raw data from LLM will be pure JSON. So in not all use cases it's going to be helpful for you. You need to have your response to be structured in a certain way. And Strands has a feature called structured output, using which you can ensure, even for security, you can use this feature. So in order to ensure that your output is structured in the way that you want, you can use the structured output. So next one is conversation management. So this is again about how do you control the context. So there are certain features like reducing the context. So you can define for how many messages you want the context to be. So if you want the context to retain for 10 messages, you can do that. If you feel that you want the context to be defined for 5 messages, from the 6th message you want to clear off the memory, you can control that. So all of this is possible through conversation management. So each of these which I am showing, they are listed as features in the Strands documentation. So these are tools. Tools is widely used. Without tools there is no AI agent, and in Strands all you need to do is you define a function, a Python function or any of your favorite coding function. All you need to do is add tool. So when you sign your function with add tool, it becomes a tool. And in your prompt, you can say when XYZ happens, call this tool, right? So it is as simple as that. And this is one example of calling tools. And if you have multiple tools, right, you can also define in what sequence you want to call the tool. So sometimes you might want to call a search tool and then a summarizing tool and then an emailing tool. So you want to call these tools in 1, 2, 3 sequence, and that's possible with tool executor. Okay, so in the interest of time, I'm just going to go a little bit faster. So security, as I said, all the elements of responsible AI, right? Security, accountability, fairness, transparency, and PII data masking. All of these is available in Strands out of the box with very minimal coding, and monitoring as well. So observability. So logging, at every AI system, it is mandatory for it to be as transparent as possible. It's your duty to ensure that all the logs are available and they are audited, because there are quite a number of regulations which your multi-agentic AI system has to comply with. And your auditor will ask for a system which is clear enough where all the logs are deposited and you are auditing on a day-to-day basis. So observability is a key requirement for an agentic AI to go into production, and Strands has again those features as well. So you have traces, you have metrics, and then logs. Okay, I'm just going to pull a small demo. Okay, this is just to okay. So this is just to show how the concept of agent loop works. So I have applied this to a very simple pharma industry use case. So the background is, okay, so the background is there is an inventory, okay, there is an inventory management, and there is a persona who is responsible to ensure that the medicines are in stock. Then there is a sudden shortage. So the system identifies that there is a shortage in medicine, all right? And then the agentic Strands comes into action. So whenever the threshold is below a certain number, the AI agent is triggered. So it starts the loop. Okay, so when it starts the loop, you will see how it's behaving. So the orchestrator agent, so every multi-agentic AI will have one master agent which will get triggered when some event happens. So here the pill quantity goes down and that gets triggered, and you can see the series of tools which are executed. So you can see with the timestamp, right? So these are the tools which are the tool execution log. So these are the various tools which are called one after the other to ensure that the pills are brought back to the normal level. So what happens is, one of the pill is going below the level, so that agent gets triggered. It calls the tool which will search for vendors. Then another tool will optimize and it will take a decision as to which vendor has to be placed an order. So another agent will place an order for the pill, and then the inventory is closed. Okay, so this is the independence of this is the level of independence that we are trying to achieve, or we have already achieved with AI agents. All right. So another example of a simple tool is a search tool. So this is a web search agent. So this is a very simple example for you to get started with tools. So this is just one LLM and a tool for doing web search. So I have used Tavily API here. So I have created an agent with Strands, and I have written a tool to call Tavily API. So the search string that you are putting down on the search text box, it will go to the agent. The agent will pass the search string to Tavily API, and the output that you are seeing is the output from Tavily. Okay. So yeah, so that's about it. Okay, I think my time is up. Any questions you have? Okay, thank you. Thank you.